Okay, today we're going to start transformations. So what's transformations? It's when you take a point on our XY plane. So here's our XY plane, and we take our original point here, X and Y, and we're going to transform it so it shifts to a different position, via some rule. So we're going to have some rule that'll shift this point up to what we call the image. Okay, so this is the X image and the Y image. This little dash represents the image point. Okay, after we've applied some rule to this point, it's going to move to this point. Now it could be as simple as a translation. So this is translation is just when you move it left or right and then up and down. So that's what we're going to start with. So what if we move this point? We're going to move it h units to the right. So we're going to move it this far to the right and then k units up. So what's our image going to be? It's going to be whatever x was initially plus h units to the right and then k units up. Okay, so our y point is going to move plus k. All right, it's as simple as that. Okay, let's move on to the next one. Okay, applying translations to graphs. Okay, so you might not just pick one point to transform, but you might do it to a whole graph. So let's say you had y equals x squared and you wanted to move it 1 unit to the right and 2 units down. Okay, so we're going to start with all our points on our xy. Okay, and we're going to map them so they go 1 unit to the right, so x plus 1, and then 2 units down, so y minus 2. Okay, so our x image is this bit. Okay, so our x image is x plus 1, and our y image is y minus 2. Okay, so if we want to work out what our y image graph would look like after we've applied these transformations to this graph, I've got this graph in terms of y and x. So I need to rearrange this formula to get x and y as the subject. Okay, so if I rearrange this one to get x as the subject instead of x image, I'll get x image minus 1, moving the minus 1 across. And then moving the 2 across, I get y image plus 2. Okay, so once we've done that, okay, then I've got my rule that I want to apply that to. I've got x and y. So for every x in this formula, I put in x image minus 1. And then for every y, I put in y image plus 2. So let's do that. Make a little thing over here. So I've got y equals x squared. So my y is y image plus 2. It's going to equal to x squared. So I'm going to put in x image minus 1. X image minus 1 all squared. Okay, so this is my y and this is x. Yeah. But now I've got it in terms of the image, so the x image and the y image. So I could expand that out and get a formula for y image. Yeah. So my y image could be written as x image minus 1 squared minus 2. That would be in turning point form, which is lovely. Or I could write it as y image equals, if I expand that out, I'd get the x image squared minus 2x image plus 1 minus 2. X image squared minus 2x image minus 1. Okay, so I could expand that out and write in that form as well. Okay, next one. Now, translations are pretty straightforward. Okay, but dilations is if we stretch it out either left and right or up and down, or squish it in. So I could squish the whole thing down or squish it in this way, make it narrower. Okay, so that's what dilations are. And the way they work when you're transforming a graph is if you take your x or y and you multiply that by some factor. So if you're multiplying your x or y by some factor, then you are dilating it. Okay, so in this case, what would happen? If I take all my x's and I multiplied them by a factor of 1/2, what would happen? It would squish in this way. Okay, so it's a dilation of factor of 1/2. Okay, that's this number here. Okay, and it's getting closer to the y-axis. Okay, so this is from the y-axis, it's getting closer in. Even though it's applying to the x here, because x runs perpendicular to y, I suppose, you're bringing it closer to the y. Okay, so from the y-axis. Okay, so what does my x image look like? My x image is 1/2 of x, and my y image is just y. And then we rearrange for x and y. So this is, you'll see this standard procedure. You write out your x image and your y image from the transformation, then you rearrange for x and y. So we get 2 times the x image. Oh, sorry, yeah, 2 times the x image, and that's just equal to y image. Okay, so if we're going to apply it to this graph, y equals x squared, what are we going to get? Okay, so let's do that. Y equals x squared, so for every y, I put in y prime. That's easy for this formula. And then for every x, I put in 2x image. So I'm going to have to put a bracket there, 2x image, and that's squared because it's x squared, yeah? Okay, so look, I don't have to do too much to rearrange this. Y image is going to equal 4x image squared. Done. Okay, so that has the effect of, if you squish it in this way, you get this graph by a factor of 1/2. That's what you get. Okay, next one. All right, dilations continued. This time, we've got a factor 3 here in our mapping. So our y is going to map to 3y instead of x. Okay, so if you imagine the y here mapping to 3 times that amount, it's going to stretch it up this way. So this is going to be from or away from the x-axis. Yeah, if you're stretching it from the x-axis here. So this is going to be a factor of 3 from the x-axis. Okay, so this is something you've got to really understand, that when you've got a factor 3y here, it's going to be from the x-axis. Okay. All right, so our x just maps to, or x image just maps to itself. Yep. And our y image, that maps to 3 times the original y. So if we rearrange that, we just get, well, that's already done. Y is equal to 1/3 of y prime, or y image, sorry. Okay, so, okay, let's put it in this one and see what we get. So for every y, we're going to write 1/3 y. Okay, for every x, we're going to just write x image. Okay, or, x image squared. Done. So that means y prime is equal to 3 x image squared. Done. Okay, next one. So we've done translations, we've done dilations, now we're going to have reflections. So a reflection in the x-axis, so we're going to flip all the y values from, if they're in the positive quadrant, to the negative, or the other way around. So you might be able to guess what this is. So that's, our x is just going to map to x, not going to change, but our y values are going to change in sign, so it's going to be negative y. Okay, so our x image equals x, our y image equals negative y. We rearrange. What do we get? Well, it's exactly the same. Okay, so if we were to do y equals x squared again, let's just do a quick y equals x squared. So we're going to start with y equals x squared, and then we're going to use this transformation here. So our y is going to be negative y image, and our x is still going to stay the same. So our y image is going to be negative x image squared. Done. So it'll look the same as this, but with a negative out the front. And you might be able to guess what happens with our reflections in the y-axis. Okay, so our reflection in the y-axis, we're going to flip the sign of the x values. Okay, so they're going to stay the same. So then our x image is negative x, and our y image is just y. Rearranging. These are very simple to rearrange. What will happen to our x squared graph? Okay, let's have a think about this. If we put in y is the same as y image, okay, and x is going to be negative x image squared. When you square that negative, what do we get? We get a positive answer, don't we? So this is going to be x image squared, which is the same graph. We didn't do anything. And that makes sense. If we've got a parabola, well, our y equals not any parabola, but this parabola in particular, because it's an even function. Remember what an even function is? It means that it's symmetrical about this y-axis. So if you flip it on the y-axis, you get the same graph. Okay, so f of negative x is equal to f of x. That's an even function. Okay, and x squared is an even function, so it doesn't change. All right, let's have a look at combination of transformations. Okay, so here we're getting to the nuts and bolts of things. What happens when we've got all these things? Now the order really matters here. Okay, so whatever order they're listed, they're the order I have to apply the transformations. Okay, so I'm going to start with this graph. Okay, y equals square root x, and then I'm going to dilate by a factor of 3 from the x-axis. Okay, so that's away from the x-axis. So away from the x-axis, it's going to be 3 times y. Okay, so that's all my points are going to map to that point. That's the first bit. Then I'm going to do this one. So I'm going to start with this, and then I'm going to reflect it in the y-axis. So to reflect it in the y-axis, I change all those x values. Yeah? Okay, so I'll start from here, and then I'm going to translate 2 units in the negative x direction. So I've started with negative x, so I'm going to move that left 2 spots. Okay, this is going to stay the same for now. Then I'm going to translate it up 5 units. So translating up 5 units. Okay, so I've got 3y plus 5. Okay, so now we've got to this point. We've done all of those in order, got to here. So my x image is negative x minus 2, and then solving for x, which is a very important step. So solving for x, well, it just looks the same, really, doesn't it? It's minus 2. If I rearrange this to get x as the subject, this comes over, becomes positive, this comes negative over this side, so it looks the same. Okay, so then our y image is 3y plus 5. This is going to look a little different when I rearrange for y. I'm going to get the y image minus 5 all over 3. Okay, and then I'm going to apply it to the graph here. Yeah, so for every y, I'm going to put in y image minus 5 over 3. Y image minus 5 over 3 equals x. I'm going to put in this. So square root of x negative x image minus 2 under that square root sign. And then rearrange for y image, and I've got it. So if I times it by 3, y image minus 5 equals 3 times negative x image minus 2. Add the 5, y image equals 3 negative x image minus 2 plus 5. And there we go. Got the graph of that image there through all these transformations, okay? Using this step-by-step process, you can never really make a mistake. All right. However, I am going to teach you how to do it by inspection as well. And if at the very least, that'll help you check your answer. So we're going to start with this graph, or in the function notation at the very least. So we're going to start. This is exactly the same as what I had on the other board. Dilation 3 from x, reflection in the y, left 2 and up 5. Okay, so we're going to go in that order. Now, if you're doing it in this notation, you need to write for every function. You need to change the name of it somehow. You just can't write f of x for every line and then change it completely, because this f of x is not the same as this one. Okay, so you just put little subscripts 1, 2, 3, 4, and you're good to go. Okay, so f of f1, f1 of x is going to be a dilation of 3 from x. So I'm going to multiply all my f of x's by 3. Okay, so that gives me 3 root x. Okay, a reflection in the y-axis. So I'm going to change all my x's and make them negative. Okay, so f of 2 is going to equal f of 1. All right, the same as this one, but I'm going to change those values of x, okay, to make them negative. So that makes me 3 negative x. There we go. Then I'm going to take this graph and I'm going to move it left 2. So to move it left 2, so I'm going to take f2 x minus 2. And you're thinking, why am I using plus instead of minus here? Okay, so the reason is when it's because of that rearranging step. When I do the rearranging step, this is what I get. Okay, so when I put that into my, for every x in this one, I've got to put in, x plus 2. That shouldn't be a negative here, yeah? So for every x in this one, I've got to put in x plus 2. So I go 3 square root of negative x, which is x plus 2. Okay, now that's a tricky step where people could make a bit of an error. That's why the other method is good. It makes you a step by step and makes it almost impossible to make a mistake. Whereas people could easily get tripped up here by not making this positive. Okay, and then we take this one, we're going to move it up 5, which is going to be f of 3 of x plus 5. So I'm just going to add 5 onto what we had, which is the same graph we had before. Okay. Okay. Determining the transformations. Now, which way did I do this first? Let me have a quick scroll through my notes. Okay, the formal way, the proper way, and then we'll do it by inspection afterwards. Okay, so we're going to have a look what transformations took place to go from this to this. Okay, so let's rearrange this in a formula. Okay, so this, if this was the original function, then this is really the image function. So let's put the little image signs there so we remember. Okay, then we'll rearrange it. So we'll get y image plus 3 equals the square root of 5x image minus 2. Okay, so that means, like, if I'm looking at this, what did we do? Okay, so for the y's here, we replaced it with y image plus 3, and for the bit under the bracket here, for the x here, we replaced that with 5x image minus 2. So we could write down that as our x imaged was 5 of the original x minus 2. Okay, and our y, no, sorry, I'll back that up. Yeah, I'll fuck that up. There we go. And our y, sorry, there we go. Get it around the right way. So our x was equal to this, our 5x image minus 2. That's better, much better. Makes much more sense. And our y is equal to this, y image plus 3. Okay. So if we're trying to determine what transformations took place, we've got to go backwards the other way and solve for our images. Yeah, okay, so our x image was equal to, if I move the 2 across, then divided by the 5, x plus 2 over 5. And our y image was equal to y minus 3. Okay, so we're doing this whole thing in reverse. If you start with this, then do the whole thing in reverse, what we've been doing before. Okay, so our x, y map to, let's do the whole thing. our x image and our y image, which was x plus 2 over 5 and y minus 3. Okay, so then we can read off our transformations here. So what transformations have happened? Okay, so the first thing we did was we moved it right 2. Okay, so we moved right 2, or translated right 2, translate right 2, and then we dilated factor of 1/5. Which way is it again? It is going to be from the y, isn't it? Just going to squish it in. And then we move down, or translated down, if you like, move down 3 units. Okay, so there are our transformations that have taken place. Now, we could have written this in a different way and it'd be exactly the same thing. So I could have split this up into x mapped, xy, oh, I made a mess of that, mapped to x on 5 plus 2/5, comma, y minus 3. Now, if I wrote it like that, then what I could say is I could have done this dilation first and then moved right 2/5. So if I swap this around, okay, swap those two around, it would have been move right 2/5 after the dilated factor of 1/5, and then move down 3, and that would have been the same. Okay, I won't write it out, but you get the idea. Okay, determining transformations by inspection. Okay, so I've got the same graph up there. Okay, the way you can do it by sort of inspection is you write the function in lonely x form. Okay, so lonely x form is we want the x by itself. So this 5, we want to move that, bring that out. Okay, so I'm going to write that as 5 bracket x minus, but if we take the 5 out, I've also got to take it out of this 2, so that this was 2/5, yeah? And then minus 3. So this is the same as this. I've just taken 5 out of this term here, okay? These two terms. Okay, so now I'm in lonely x form. There's no coefficient for the x, okay? So the lonely x, got to get the x by itself, okay? Now if the x is by itself, then I can list down the transformations in this order, Dr. T. Okay, so you just remember Dr. T, and you do the dilations first, then the reflections, and then the transformations. So I'll do D first, the dilations, factor of 1/5, okay, from y-axis. So when you've got a dilation from the y-axis, right, it's going to be 1 on whatever this number is in here, okay? 1 on the number that's in front of the x, basically, okay? Now, if that 5 was out the front here of it, it would be a factor of 5 from the x-axis, so that would have been different, yeah? So it's only when you've got a from the y-axis, it's going to be 1 on whatever the factor is, okay? Do we have any reflections? None. Okay, so don't worry about that. Translations, we've got a move right, okay, right 2/5 and down 3, okay? So we've got to remember our left and right signs are sort of flipped in this notation, yeah? So this is why it can be a bit tricky. Here we've got this, which is a factor of 1/5, and this is right 2/5, and this is down 3. So it can be tricky. Just got to make sure of it. Plenty of practice makes perfect. Okay. Okay, now we're going to sketch this graph. Now that we've talked about all the transformations that happen, let's sketch it. Okay, so first thing I'm going to sketch is the graph of y equals root x. Okay, so that we need to know what this looks like. Okay, curves around like that. Well, it's x to the 1/2, so it's that power function. We start at 0, 0, and it goes through 1, 1. Okay, we know that already. Then we're going to do the dilation by a factor of 1/5. So I'm going to sketch the graph of root 5x. So if I'm squishing it in by a factor of 1/5, it's going to squish right in. Okay, now that probably doesn't look much different, but it doesn't really matter as long as we write the right thing here. So I've got 1/5 and 1, and we're still at 0, 0 because that was on the y-axis. So that's not going to change. That's just going to push it into it. It's like the y-axis is a wall here that you're pushing into. Okay. All right. So then what are we going to do next? We'll do the move right 2/5. So I'll go y equals 5x minus 2/5. Okay, hopefully you can see that. I'll just move that just to make sure. Oops, what am I doing putting that there? Shouldn't put that there. Should move it right 2/5. Have this shape. So I've got right 2/5, 0, and then this bit was 1/5. So if I move it right 2/5, that takes me to 3/5, 1. Okay, and then I'm going to move the whole thing down 3, and that'll get me to the final thing. So x minus 2/5 minus 1/3. Okay, so move the whole thing down 3. So I'm going to start here at 2/5 negative 3. And then I'm going to go like this, plot that graph. And, well, this 3/5 bit, move the whole thing down 3, so that is going to be at 3/5 negative 2. And we've got it. Okay, so that looks like a really tricky graph to draw, but if you sketch it out one step at a time using each of the transformations in the right order, then you always get the right graph. And it becomes pretty easy. Let's do another one. Do a bit of a trickier one, here we go. So I'm going to continue this. We're going to draw this graph. So what's the implied domain of this graph? Okay, so we think about, well, can x take any value? Well, it can't take a value if this denominator is going to be equal to 0, because that'll be no good. So if that's going to equal 0, I can't have x equaling 2. So as long as x is an element of R excluding 2, then we're good to go. So as long as I exclude that 2, then this is all going to work. So what transformations are going on here? This is a bit tricky. We're going to have to do something a bit different here to work out what the transformations are. Okay, the trick to this one is to notice that this is a linear on the bottom and a linear on top. These are of the same power. So if the power on the top is greater than or equal to the power or the order on the bottom, so this is linear and this is linear, then you've got to really do the long division to work it out. But when we do long division for a linear on a linear, it's quite an easy thing to do. So x minus 2, 4x plus 1 goes in 4 times. 4 times x is 4x. 4 times negative 2. So that's 4 times negative 2 is negative 8. I minus them away from each other. 4 minus 4 is 0x. 1 plus 8 is 9. Okay, so now I'm done. That's the whole long division. So I can write this f of x, f such that, let's write the whole thing out, function notation. R excluding 2 maps to R, okay, comma. So we've got f of x equal to, what have we got? We've got 4 plus 9, the remainder here, on x minus 2. Now that's a graph. I can see all the transformations now. It's much easier to do. I can say, oh, it's this graph, 1 on x, that's been, it's been dilated, it's been shifted and shifted. Okay, so let's write them out. I can do it by inspection. I want to do it by inspection? Sure, by inspection. Let's do it by inspection. So x minus 2, well, let's do the dilations first. Dilation, factor of 9. Okay, so factor of 9 from which axis? From the x-axis. Okay, and then it's moved right to, so there's no reflections, and move right to and up 4. So right to, up 4. Okay, so I'll just start with a sketch of this, and then we'll work our way through. So let's sketch 1 on x. Now 1 on x looks like this. Okay, remember the asymptotes. X equals 0 and y equals 0. It's going to go through 1, 1 and neg 1, neg 1. Okay, and then what's going to happen? It's going to stretch out. Okay, so it's going to go 9 from, if I stretch it out. So I'll just draw the same thing, right? And if you're clever, you can just change that to a 9 and that to a -9, and you've got the dilation all in one graph. You didn't actually have to do much, you just change this number. So the graph is going to look the same. Just that point, it's going to change from -1 to -9. Okay, and you can label the asymptotes as well, but no reflections. We're going to move it right to and then up 4. Can we do this in one go? Let's do it in one go. So right to and then up 4. Okay, so right to, so that's going to take my asymptote to 2 and up 4. Take this asymptote to 4. Okay, and then I'm going to draw that in. Oh, this is a little bit trickier. I've got to just make sure I get all this on the right side of the line. Now, we'll talk about that in a minute. Okay, so how do I know to go below the line, sort of cross the x-axis before the y-axis and not cross the y-axis then the x-axis? Well, you're going to have to check. Okay, so that's basically what it comes down to. So this is going to be right 2, so that's going to be 3 and up 4. Takes it to 13. And then this point, right 2 and up 4. So we're going to go to 1, -5, 1, -5, and then you can check to see what happens for the graph when you put in x equals 0. So what do I get when I put in x equals 0? I get 4 plus 9 on 2, which is 4.5, or -4.5. So 4 minus 4.5, which is taken to 1/2. So this point here is 0, -1/2. Okay, and that gives me the clue that it crosses below the x-axis. Okay, you can also work out what that point is. Okay, and it's -1/4 0. Okay, you put 0 in for y, solve for x, and you get -1/4 0 there. Okay, let's move on. Okay, graphing power functions. This is another example, really. This is pretty much the same thing. Okay, so what's happened to this one? We'll use the other method this time. Instead of by inspection, let's do the formal mapping way. Okay, so rearrange. Let's rearrange this. Okay, remember this is my y image and x image. Okay, so I want to get, well, I'll go for the blue. So y image plus 3, equals negative x image plus 1 cubed. Okay, so if my original graph was y equals x cubed, what's happened to my y? So my y has turned into y image plus 3, and my x has turned into, how do I want to write this? Let's write it as my, well, what I could do, which is probably a little bit better than leaving the x there, because that's not really what's happened to the x. So the x, what's happened to the x is turned to x image plus 1. Yeah. Look, I could put the negative outside there, but actually I might just move this negative over to this side. Okay, that makes it easier for me to handle. So that's what I'm going to do. Okay, so then that becomes that. So my y became negative y image minus 3. X became x became x image plus 1. Okay, so I can then rearrange for the images here. Okay, so rearrange. What do I get? I get the y image equals negative y minus 3, and my x image equals x minus 1. Okay, so what are my transformations? So my x and y map to the x image and the y image. Okay, so my y image, oh, let's do the x first. It's just moved left 1. Okay, so translated left 1. What else have I got here? I've got a reflection in the x. So reflection in x-axis. Okay, that's this negative here, and then moved it down 3. Translated down 3. Okay, and then we can graph that. So let's do that. You know, it's always good to write it in order as well, in terms of Dr. T. So you've got no dilations, then the reflection, and then these translations. So I've kind of mucked that up a bit, but in this case it doesn't actually matter. But okay, let's do it. Okay, so we start with x cubed. So we know our power functions drawn like this. Okay, and then I'm going to, well, let's do the reflection first. It's pretty easy. So this bit's going to flip up here. Okay, so 1, negative 1, and negative 1, 1. Okay, so that's our reflection. Left 1, down 3. Let's do it all in one step. So left 1, down 3. Remember, this is at 0, 0, so we can use that point. Left 1, down 3. Okay, so I haven't drawn these very good because I should be trying to get that stationary point in there. So I've done it a little bit better here, get a flat stationary point, which means it comes to an absolute flat and then moves back up. Okay, so what have I got? Negative 1. Now, what did we do? We went left 1 and down 3. Okay, so what happened to this point? This point came down to 0, negative 4. What happened to this point? It went negative 2, negative 2, down 3, negative 2. Okay, and there's our graph. You could also find this point if you'd like by sticking 0 in for y and solving. Okay, so if you've got the graph, how do you determine the rule? So let's have a look at this graph. Now, it's in the form, or given the form. A, it's not a 9, it's an A, x minus h squared plus k. So we're going to find the values of A, h, and k, looking at this graph. So we should know that this is a truncus, and we know what form truncuses is. We know what form truncuses are. So we've got y equals 1 on x squared. Okay. Okay, so what's going on here? We know that graph, what it looks like. Yeah. So we know this asymptote is going to be between these 2 points. Okay. It's an even function. 1 on x squared is an even function, so we know that these are symmetrical. So this asymptote is going to be right between 1 and 3. Okay, so it's been moved to the right 2 spots. So that gives us our h straight away. So we've got y equals a over x minus 2 all squared plus, I'm going to write k squared, just plus k. Sorry. All right, we've also got k. K is given by our asymptote. Our asymptote that we've moved up 4, which is going to be our k. So we've actually got y equals a on x minus 2 all squared plus 4. So we've got 2 spots just by looking at the graph. So now all we need to do is try and find our a. Okay, so to find a, we can stick in one of our points. Let's stick in this 3, 1, and see if we can solve for k. Okay, so we've got y equals, a on x minus 2, so that's 3 minus 2, all squared, plus 4, and that is going to equal to 1. Okay, so that's putting in this point. The x is 3 and the y is 1. Okay, so we get y, 1 minus 4 equals a. This is 3 minus 2 squared, which is 1 squared. So we get 1 minus 4 equals a, which is negative 3. So a is negative 3, and we're finished. So we've got y equals negative 3 x minus 2 all squared plus 4. And we're done. Okay. And when I say done, we're just done for that question. Of course, there is always yet another board. Okay, so determining the rule. Okay, so in this case, this is work example 19 from the textbook. You've got 2 points that lie on an equation here. So how are we going to find our a and b? Okay, so we're going to solve simultaneous equations. Put each point into the equation, get 2 equations and solve those simultaneously. Okay, so let's put in 2, 1. Okay, so 1 is equal to a x minus 1, so I'll go 2 minus 1 plus b. If I simplify that, I get the square root of 1 plus b. The square root of 1 is just 1, so I get a plus b. This is my equation 1, so I'll label it like that. Okay, let's put a little box around it. Even better. Okay, now let's do 10 and 6. So I get 6 is equal to a 10 minus 1 plus b. So 6 is equal to a root 9 plus b. 3a plus b. This is my equation 2. Okay, so now I want to solve this equation. So we can do that by saying, we'll let a equal to 1 minus b from equation 1, and then sub it into this one. So we get 6 is equal to 3a, which is 1 minus b, plus b. Expand it out, I get 3 minus 3b plus b. Okay, and then what do I get? 6 equals 3 minus 2b. Is that right? So then I move this 3 across the other side, and I get 3 is equal to negative 2b and then therefore b is equal to negative 3 on 2. Okay, so once I've got b, I can substitute it back into this one to find a. So I've got, here we've got a equals 1 minus b. 1 minus b, which is negative 3 on 2. So 1 plus 3 on 2. 2 on 2 plus 3 on 2 equals 5 on 2. Fantastic. Okay, so now I've got my equation. Y equals 5 on 2 square root of x minus 1 minus 3 on 2. Finished. Okay. Okay, for the next few slides, we're going to be using matrices for the transformations. Now, this looks like a pretty intimidating slide. It's quite out there. It's got lots on it. So let's just work our way through it. It's actually quite easy. It just looks like a lot in one page. Okay, so if we looked at our reflection in x-axis, okay, so that means our x images would stay the same as our original x's, and our y images would flip to the negative of our original y. Okay, so that's a flip in the x-axis. If we were to write that out in full with x's and y's, okay, so our x image is the same as x, which is the same as this, plus 0y. Okay, so I can imagine having 0y on the end of this one. Right? Same with this one. I've got 0x, nothing happens with x, and the y is flipped, so I get negative y. Now, why would I do that? Why would I put in these zeros here for the x's and y's? Okay, so the coefficients of our x's and y's in here make up our matrix. Okay, so our transformation matrix here, okay, is just the coefficients of these numbers. So we're not actually learning anything new here. Like, we're just learning how this relates to our matrix step. So this is the most important column here. But you can always work it out by writing out the image equation. So as long as you can write the image equation, okay, just put both x's and y's in, and then you can work out your matrix. Okay, so reflection in the x-axis. So that means our images of x are going to be the negative of our original x's, and the images of y are just going to be the same. Okay, so we can write it out in full, and then put our coefficients in to make our matrix. Okay, so dilation factor of k, x equals kx from the y-axis. Okay, so we're going to stretch or shrink those x values. The y values stay the same. If we write it out in full, 0y there and 0x there, and we can put it into our matrix. Okay, so if we know how to make the matrix, we can do the rest. Okay, so we've got dilation factor of k from the x-axis. The k there, and then this is a neat one. Once you start writing them out in full, you can think, well, hang on a minute, maybe I could have the x image be the same as the y, and the y image be the same as the x. Okay, and that would be a reflection in this line, y equals x. And we all know the reflection in the line y equals x is the inverse function. So if we're trying to find an inverse function, maybe we could do this with matrices by using this matrix. Okay, that's something to think about later on. And translations, so it's moving left or right. When you've got A and B, so the matrix is just adding on this matrix here. Okay, so it is pretty straightforward. Let's do an example so we get the idea. Here we've got a translation or transformation of a point. So we're just going to take the point 2, negative 3, and we're going to write that as a matrix. So we're going to always write a point as a 2 by 1 matrix. Okay, 2 rows, 1 column, and the x value goes up top, y value goes there. Okay, we're going to dilate it by a factor of 5, reflect it in the x-axis, and then translate 1 unit to the left and 4 units down. Okay, so we're going to write an equation here in matrix form, so a matrix equation. So we go to our x and y images, so, well, our x image and our y image as a matrix, and that's going to equal, well, this is our original matrix. What are we going to do? We're going to dilate it by a factor of 5, from the y-axis. Now to do that, I'm just going to use the matrix from the previous slide, the previous board, and it's from the y-axis. So that means that it's the x value that's going to be by a factor of 5. So I'll put a 5 here, 0, 0, 1, and that's it. So I just, as long as I pre-multiply, okay, for each step I want to pre-multiply the, if I'm multiplying by a matrix, just pre-multiply in that order. So I start going this way. That's why I put this here and I've left a bit of space. So reflection in the x-axis. So I'll take those y values and make them negative. So I'm going to multiply by, okay, taking the y values and making them negative, okay? And then I'm going to translate. Now translation, I just add on my transition matrix, A and B, 1 unit to the left, 4 units down, and that's it. So if I multiply and do this sum, it'll give me the image here of this point. So I could do that in my CAS quite easily, or I could do it by hand. Now these matrices are going to be fairly easy to multiply together. So I'm going to do these matrices first. So what does that give me? So 1 by 5 by, so you can see what's going to happen here. So I'm just going to merge these together basically, and it is just multiplying. So you should multiply it out in your CAS and see what happens. But basically these things just are going to, because it's almost the identity matrix, just got a negative here. So they're just going to merge together all the components of them. Okay, but you know, if in doubt, just multiply them together properly. But once you get the hang of it, you'll see what's actually happening. Okay, so now I'm actually going to multiply these properly together. So what do I get now? I'm going to get a 2 by 1 matrix, all right? The rows from this one, the columns from this one. So I get 5 2s are 10, and that's it. And then I get 0 and -3. There we go. And I've still got this one to add on. And that gives me 10 minus 1 is 9. -3 minus 4 is -7. And that's it. Let me just check and make sure I got that right. Doesn't look like I did. Let me have a look. Oh no, I think I did get it right, did I? I made a mistake. No, I didn't really. I just didn't put my negative in here and follow it through. So I got a slightly different answer. So let's just change the question. I think it's okay. Let's just make that +3. This was 2, 3, and then it's fine. Okay. Now you probably can't do that little trick on your exam by just changing the question. You would have to change your answer. Okay. So let's get rid of that board. But because I'm not doing the exam, I can do that. Okay. So let's do transformation of a graph. Okay, so we're going to take a graph. We're going to dilate by a factor of 3 from x, reflect in y, move left 2 and up 1. Okay, so what is that going to look like? Let's put it all in one here, all in one go. So dilation factor of 3 from x, that means it's going to go stretch up parallel to y. So those y values can be through, oh, I don't need to put the y there, just the number 3 in that spot. Okay. Then I'm going to reflect it in the y. So those negative, x values are going to become negative. So I'm going to make those x values negative. And then I'm going to move it left 2 and up 1. Left 2, up 1. Okay. So it's as easy as that. Let's then work out what happens to this graph. Okay, so what's my x image? My x image is going to be when I multiply these bits together. So I get -x plus 0y minus 2. So -x plus 0y minus 2. Well, I don't need to put the 0y in there, so let's just do that. Okay, so that's my, and then I rearrange for x here. I get negative x image minus 2. Let's do the y's. So the y is going to equal 0x plus 3y plus 1. So I get 3y plus 1. Rearrange for y. I get y image minus 1 all over 3. Okay, so that's my equations. I can then sub in to my equation to find the image of this. Okay, so my y's become y image minus 1 over 3 equals negative x image minus 2 squared minus 4 negative x image minus 2 plus 3. So for every x in this equation, I substituted in this. Okay, so let's find out what that is. If I expand that out, what do I get? I get, well, these negatives are going to go away, aren't they? So I'm going to get x image squared plus 4x image plus 4. I can go plus 4x image plus 8 plus 3. Those are nice, all the negatives cancelling out, makes it a bit easier. So x image squared, 4x and 4x is 8x image, plus 4 plus 8 plus 3 is 15. Oh, and then I have to multiply the whole thing by 3 and minus 1. Okay, so multiply the whole thing by 3 minus 1. Okay, let's do it. Okay, so that's my y image. 3x image squared plus 24x image plus 45 minus 1 is 44. Okay, and that's it. Okay, so that's my y image equation. Actually, didn't have that in my notes, so I've mucked that up. Okay, but I think I got it right this time, which is great. Okay. Let's do another one. Okay, now this time's a bit more complicated. We've got a few more complicated transformations, but we've got a nice easy thing to transform. We've got y equals 2x minus 3. The first thing we're going to do it in this order. We're going to translate down 5. Okay, so to translate down 5, I'm going to add, well, I'm not moving it right or left. I'm just going to go down 5. Okay, and then I'm going to dilate it 3 from y and 2 from x. Okay, so I need to put brackets around this. So I'm going to multiply all of that, pre-multiply, okay, by 3 from y and 2 from x. Okay, 2 from x is parallel to y, and 3 from y is parallel to x. So I've got that there. Then I'm going to reflect in y. So I'm going to make all the x values stay the same, and the y value, oh no, all the x values are going to flip to negatives. Okay, and all the negatives will flip to positives. And then we're going to go right 2 and down 1. So I just add this on at the end. Right 2, down 1, and we've got it. Okay, I left a bit too much room here, but that's okay. What is our x image? Then let's just do the x image bit. Okay, so we're going to start on the top, find this bit here. So we go negative, oh, actually, we can put these together in one go. So this is x plus 0, which is just x. So let's go negative 3x plus 0y plus 2. So it's negative 3x plus 0y plus 2. Okay. Then our y image equals the bottom row, so 0x plus 2y minus 5. So 2y minus 5, well, y minus 5 multiplied by 2 and then take away 1. So y minus 5 multiplied by 2, then take away 1. Okay. Now if I rearrange these for x and y, okay, so what's x? X is going to be x image minus 2 divided by negative 3. Okay, and our y is going to be, what do we get here? Let's expand. Should we expand? It depends what we want to do. Let's expand. Okay, so we'll expand this first. So 2y minus 10 minus 1. Okay, so it gives me minus 11, doesn't it? So I make that minus 11. So then I get y image plus 11 over 2. Okay. You don't have to do it like that. How did I do it? Oh, I did it the other way, which would have been to minus the, or add the 1, divided by 2, then add the 5 at the end. Okay, so I could have got that, or I might even use this the other way around because it might be a bit easier. Or y equals the y image plus 1, all divided by 2, and plus 5. Yes, I think I'll use this one because that might be easier to do. But either one will still get you the same answer. So we're going to do whatever we like there. So if we make that transformation, so I'm going to use this one and this one. Okay, so let's put this in for y. Okay, I'll do it in black. Running out of room here pretty desperately. Okay, so we'll do our best. So I've got 1/2 of y plus 1 plus 5 is equal to 2 times x. So I get negative 2/3 of x image, I forgot to put the image sign there, image minus 2. Yeah, so it's 2 times it. So I've got 2 times this, minus 3. And then if I expand and solve, hopefully it will get me to a good spot. Negative 2/3 of x plus 4/3 minus 9/3. This is 9/3 here, which is negative 3. What does that give me? Oh, geez, running out of room. Really bad. Okay. So let's go. Well, this is half of y prime plus 1 equals, I'm going to put the minus 5 on the other side. Maybe I should have just done that to start with. Make that minus 8. Let's get rid of this. Minus 8. So then I want 8/3. Okay, so it's going to become 24, isn't it? So that puts that together. 24 minus 4, so I get minus 20 on 3. So I've got minus 2/3 plus, minus 2/3 x minus 20 on 3. Times it all by 2. Negative 4/3 minus 40/3 minus the 1. So I get y prime, x, minus 4/3 x minus minus 1, so it's 43 on 3. Hopefully that's correct. That's the same answer as I got before. Beautiful, excellent. Okay, so let's just do one more. Okay, now we're going to try and use inverse matrices for our transformations. Okay, so here we can see I'm defining my xy, my original point in the matrix, as matrix x, and then x image as x image, y image. Okay, so this is the equation we ended up with before, okay, which is in this form here. So the x image here is equal to a multiplied by our original x plus b plus c. Okay, so they are transformations matrices there. Okay, so if we rearrange this matrix to find x, on its own, well, we minus C. Okay, so we end up with this. Now to get rid of this A, instead of like dividing by A, you don't really divide by a matrix, right? So we take the inverse matrix, okay? So the inverse matrix is like the inverse operation for matrices, yeah? So when you have like just a number multiplied, right, the inverse operation is to divide, right? That's why we divide by the number. But for matrices, we don't really do that. We just take the inverse operation, which is just the inverse matrix, okay? All right, so we put that over the other side, the inverse matrix here. Now that's -1, and this is like a little comma or a little apostrophe, if you like. So this is our x image is an apostrophe. The inverse is -1. Okay, so I end up with x plus b left over minus the b, and I get my original matrix here. Okay, so to do this, we can just plug it straight into here, except we need our inverse matrix. So we need to know what an inverse matrix is. So for a 2 by 2 matrix, what you do is you go 1 divided by, and you multiply, you basically cross multiply here, and you go these two multiplied together minus these two multiplied together. So I've got -6 minus 0. Okay, so that's easy. And then you take the diagonals and you swap them. So everything's done on the diagonals here. So you just swap those diagonals over, 2, -3. And then these diagonals, they stay in the same position, but they become negative. So you take -0 and -0 in this case, which is still just 0. But if they were numbers, you just take the negative of that and the negative of that. Okay, so that's our inverse matrix. Okay, so now I can put it straight into here. Okay, and solve. Okay, so let's get them in the right position. So I've got our, I'll do it over here. Let's go with our xy. Original xy is going to equal A inverse, which is 1 on -6, 2, 0, 0, -3, multiplied by our x image, y image, okay, minus c. Now where was our minus c? That's this one. So instead of minusing c, right, I'm going to add on and just change those values, yeah? So instead of having 2 and -1, I just change the signs here, -2 and +1, okay? Now that's -c, okay? Minus b, and b is this one, okay? So I want to, again, change the signs, so 0 and 5. Okay, so what does that give me? For my original point, I get x equals, so -1/6 of, now I'm doing the x part here, so I'm going across here and there. That's how I look at it. So I go 2 times x prime, so I'm going 2x prime plus 0 y prime, so I won't bother putting that in. Oh, sorry, it's 2x prime, but this is in brackets here. So I've got x prime minus 2 here. So 2 of x prime minus 2. Okay, so I should have done that first. Yeah. And then plus 0. Okay, so that gives me twice that, -1/3 of twice. Oh, sorry, I've already considered that. I don't need to put the 2 back in. That's why I made it a third. We'll just get rid of this. So -1/3 of x prime minus 2. Okay. Now y is going to equal -1/6 of, now how do I do this? I'll do this first, and then go across here, and then across here. So 0x prime minus 3 of y, I keep saying prime, but y image plus 1, okay, plus 5, okay. So what does that give me? That gives me 1/2 y image plus 1 plus 5, okay, and that's the same as the equations that we had before. Right? I don't need to rearrange now because I did all the rearranging up here. Now that might have seemed like a long way to go about it. But you can get inverse matrix on your CAS, you know, and you can put that straight in and get these equations straight out very easily on your CAS. Okay, and that's it for today.